All right, these are your notes for section 3 of chapter 7. Your objectives from this section are to describe the discovery of gene linkage and also to explain how linkage maps can be used to estimate distances between genes. This isn't actually new. This was something we did in that last section of last chapter. We made those chromosome maps. So really, we're just going to be talking more about how that discovery came about. Okay, the scientist that came up with this idea for gene linkage and really put it all together was Thomas Hunt Morgan. He did these dihybrid crosses with fruit flies, but he wasn't getting those normal Mendelian results. He wasn't getting that 9:3 to 3:1 ratio. But he was able to pick up on a pattern and figure out what it means. Okay, so first we need to talk about a couple different terms that he used. He talked about a wild type and a mutant type. Wild type was the most common phenotype, and mutant type was the least common phenotypes. Wild type was not necessarily dominant. That's not what that means. It just happened to be the thing that was the most common and was most prevalent in that population. So remember that wild type does not mean dominant. It just means that it was really common. When we were talking about blood types in that last section, type O blood is really, really common in our population, but it's a recessive trait. So again, dominant doesn't mean prevalent. It just means that it shows through when those two alleles come together. So wild type, mutant type, he was only worried about if it was frequent or not. So he wasn't really keeping track of it, dominant, recessive. So the pattern that he looked for and the pattern that he saw that those linked traits fell into 4 different groups, and he assumed that those linked traits would be located on the same chromosomes. Turns out that fruit flies do have 4 pairs of chromosomes. Their N number is equal to 4. So anytime there was that crossover that occurred, it could happen between a pair of chromosomes. So Morgan was special in the sense that he came up with that idea that you had those pairs of homologous chromosomes, and that's where that crossover would happen. And it worked out because those linked traits did fall into those 4 groups, and N equals 4 for that species, for fruit flies. They do have 4 pairs of homologous chromosomes, and that's where that crossover was happening. But anyway, we do need to do another example of linkage maps, talk about those again, chromosome maps. Linkage maps map the relative locations or loci of genes on a chromosome. So the big key in this definition is just to remember that these are relative positions. It's not exactly where it is, it just gives you the right order of those genes on that chromosome. So if we want to construct another chromosome map just to make sure that we remember how to do this, we're going to use this crossover data, put it together to make our chromosome map. Remember, you always start with that biggest separation. So the biggest separation in this case is that 20% between A and B. So I'm going to start with A and B. I'll put A here and B over here. Connect them. And then I got to figure out where C falls on that map. Remember, you're just going down from big to small. So 12 is that next biggest. C is 12%, 12 map units away from B. So I'm going to go from right to left, from B towards A, about 12 map units, which might be a little over half around here. I'm going to put C right here. This distance is 12. Remember, this distance is going to be 8 because that next piece of data tells me the distance between A and C is 8. 8 plus 12 gives me that 20 total. This is a completed chromosome map. So we've done this before. We know how that works. But now we're going to expand on it a little bit. The question down on the bottom says, if you add a 4th gene D to the mix, what would the crossover frequency between A and D be if C to D is 16% and B to D is 4%? So I need to try and add one more gene to this chromosome map that I have up here. Now, logically speaking, it has to be really close to B because it's only 4% away, and it has to be 16 map units away from C. So I could go from C and go to the left, but that wouldn't make any sense because that's just going to take me farther away from B. I need to go from C to the right about 16 map units to place this D. So I'm going to go 4 map units farther than 12 because that would give me 16, somewhere over here. That's going to be where my D falls. And again, 4 map units is how far away you're supposed to be from D anyway. So you just got to be a little bit logical when you're doing this. Just think it through. Where does that D need to be so it can be close to B and still be 16 map units away from C? But now I have that in there. And the question actually asked me, what is the crossover frequency between A and D? So I can add all those pieces together and figure out what that is. 8 plus 12 gives me 20 plus another 4 gives me a 24% crossover frequency from A to D. So that crossover frequency between A and D is going to be 24%. A is 24 map units away from D, so it's 24% as an answer.